In this example, I need to sketch the graph of the following piecewise defined function. Here's my function. It comes in two pieces. If x is less than -1, f of x equals the absolute value of x plus 3. And if x is greater than or equal to -1, f of x equals -2x plus 3. So here's my first section of the graph where x is less than -1. Here's -1, so I need points on the left of -1. Now, even though x doesn't equal -1 in this part of the definition of f of x, x could get infinitely close to -1, so I have to figure out what happens when x equals -1, but I'm going to graph it with an open circle to indicate it's not included. So when x equals -1, I get the absolute value of x, which is -1, plus 3. What is -1 plus 3? It's 2. The absolute value of 2 is 2. So the point I'm going to graph is -1, 2, and I'm going to graph it with an open circle. So x equals -1 is here and 2, so there is my first point, and now I need some points to the left. So let's figure out what happens when x equals -2. I get the absolute value of -2 plus 3. -2 plus 3 is +1. The absolute value of +1 is 1. So the next point is -2, 1. -2, 1. Now, what does the graph of an absolute value function look like? It looks like a V, and so I'm going to need to calculate some more points. So moving to the left, when x equals -3, I get the absolute value of x, -3 plus 3, which is the absolute value of -3 plus 3 is 0. The absolute value of 0 is 0. So I get the point -3, 0. -3, 0 is right there. Keeping moving to the left, when x equals -4, I have the absolute value of -4 plus 3, which is the absolute value of -4 plus 3 is -1. The absolute value of -1 is 1. So I get the point -4, 1. So that point is here. So now you can see I found the vertex of my absolute value, so I do not need to calculate any more points. I can graph my function. So I have a straight line here and then another one going up here. And then don't forget the graph keeps going to the left, so you put an arrow on the left-hand end, but you don't put it on the right end because over here the graph is going to look like -2x plus 3. One thing I'd like to point out is if you've already studied graph transformations, you know that the x plus 3 inside the function would shift the vertex of the absolute value 3 units to the left. So I'd only need to calculate these 3 points. However, if you haven't studied that material yet, you can get the same graph by just calculating more points. Next, I need some points from the second part of the graph where x is greater than or equal to -1. Well, at -1, f of x is going to be -2 times x, which is -1 plus 3. -2 times -1 is +2. 2 plus 3 is 5. So my point is going to be -1, 5. And I'm going to graph it using a solid dot since this part of the definition includes x equals -1. So the point -1, 5 is here. And now I need some more points. Well, what does the graph of negative 2x plus 3 look like? It's a linear function. It's a straight line. So I just need one more point. As long as it's to the right of negative 1, it doesn't matter which point I pick. Let's pick x equals 1. So my function is going to equal negative 2 times x, which is 1, plus 3, which is negative 2 plus 3, which is 1. So that is the point 1, 1. And so now I can graph that point. 1, 1 is here. And now graphing the line going to the right, I have that line there, and you can put an arrow pointing to the right to indicate this graph keeps going forever down and to the right, but you cannot put an arrow on the other end. So this is the graph of my piecewise defined function. Normally we don't graph it in two colors, but I did that to help you understand where the points came from.